Hello, I'm Thorsten Hapke, a product manager for SAP Data Intelligence and a member of the Frontrunner team. In the next 25 minutes, I'm going to develop new custom operators of the second generation, also called Gen 2 operators. These new type of operators are a major step forward, but undeniably require some upskilling. Of course, when you have already developed custom operators of the first generation, you have certainly some advantages, but be cautious. It might look similar, but it needs more framework preparation before you can start with the processing script. With the second generation operators, we have got a lot of crucial features that helps us writing more secure pipelines. The 5 most important ones are listed on this slide. Interconnectivity. This enables you to basically connect all Generation 2 operators provided they have compatible port types. Robustness. With the new V-types, we can type-safely connect operators and ensure at design time the compatibility. Resilience. Now we can define stateful operators. That means that you can store the operator state as a snapshot. Once a pipeline has stopped accidentally or paused, the last state of the operator can be restored when the pipeline execution is resumed. Coherence. The messages passed between operators contain, in addition to the data, separate metadata that can be used to manage the pipeline execution. For example, assign messages as a last batch. And finally, message and stream types of data flows are supported. There are some more deep technical enhancements that would go beyond this short introduction, because it would need some more explanations. Now let's have a short recap of the modeler, the development environment of SAP Data Intelligence. Therefore, I go to Data Intelligence System. This is the modeler where you find most of the tools for developing data processing pipelines. On the left, you have horizontal tabs for selecting development sections and a pane for the objects. Pipelines, or sometimes called graphs, neither the system nor I be consistent with the terms. Both mean the same. Operators with a section toggle for Generation 1 and Generation 2 operators. The Replications tab, that is specific for replication tasks only. And we have the repository. It's a kind of an explorer for the vFlow folder structure, where you can also access files and upload directly the files. The configuration types, where more advanced configurations are defined that can be used when operators have configuration parameters. The type would be then an object. And finally, we have the data types, or V-types, where you define the data types used by the ports of the operators. For our project, we are going to use the graphs, the operators, and the V-type objects. In the center, we have the canvas for putting the pipelines together. On the right opens the pane containing the configuration details of an object. And on the bottom, you get the runtime information of the pipelines. You can access the logs, or the details of the runtime pipelines. You also have a tab for the terminal. That should be enough for now. We will have a separate presentation that goes into the details on the modeler. Now let's move on to the development project. When we thought about what use case we like to underlay our presentation, we eventually decided for a real project, something of value and not an invented gimmick case. So we took a spin-off of a proof of concept we have done. We are Min-Hee Song, Christian Sengstock and myself. If a company uses SAP Intelligence productively and data is processed between different data sources, it is necessary to have a report that contains all this information. We have the monitoring app that stores the runtime information of all started pipelines, and you can set the period of how long you like to archive this information. If you like to save all details, including which data sources have been used, then you need to save the runtime logs of each executed graph on a daily basis. Wouldn't it be better to have the important data stored in a table structure on which you could, for example, create an SAC cockpit? And this is exactly what we like to develop in this presentation. There is one caveat I have to preface. Because we want to have one pipeline that retrieves the information for a number or even all users, we have to resort to private or non-public APIs. It is not secretive or dangerous to use this kind of APIs. Mostly they are used by the UI. It is just that each public API needs to be maintained or should not be changed, and therefore good justifications are required to have this as a standard API. Nevertheless, you can replace all REST API calls with a corresponding public one, and then you get the result for each user only. In case you only have a limited number of technical users, then it might be even justified. So, to put the requirements of the use case in a summarizing statement, get the runtime information of all run and completed pipelines together with what data sources have been used, and each whether as a source or a target. This information should be saved periodically and in Delta mode as a CSV file to an object store. In case of pausing or if accidentally stopped, the pipeline should resume from the latest status. By that, we can showcase almost all important features of the second generation operators. The support of streaming type data parsing is left out. How to use this feature I have described already in a blog. Just Google Thorsten Höpke SAP blog Gen 2 operator. Now let's have a look what lays ahead of us. First, we have to create a user list with an VCTL command. Of course, we could have called a private API or added a config parameter list to get this list. I decided for the option of creating a VCTL user list because I could then show the integration with one of the most used standard operators. Secondly, we have to add a new pipeline and select that we want to do this with generation 2 operators. Then use a standard operator to read the user list for which we like to archive runtime graphs. Then we have to create our first custom operator runtime graphs. That consumes the user list, gets the runtime graphs for a REST API and sends the resulting table to the next operator. In parallel, we have to add new v-types for ports and messages between the operators, based on what we have learned from the data we have got from our REST API calls. The next step is to create our second custom operator graph data sources for extracting the data sources. Finally, we use a second standard operator for saving the result to a CSV file. Because we like to run the pipeline with resilience, we add a snapshot feature to the runtime graphs operator. And finally, we create the simple third custom operator timer that enables us to run the pipeline permanently and triggers the pipeline execution on a chosen period. Let's go to our first task of creating a user list with a VCTL command. Here you see a script I've written to call the VCTL command VCTL user list. The output is piped to the shell command set to replace the tabulars with a comma in order to get a CSV formatted file. And this is the result, which we will upload to an object folder. Launchpad, we start the Metadata Explorer, browse connections, and go to the folder to which we want to upload the file. The Launchpad, we start now the modeler and we add a new graph with the second operators. And here we first select the file consumer to upload the just uploaded file. We've stored it at an S3. The connection is S3 catalog, and it was tutorial user list. Okay. Now we have it, and it has definitely a header, and that's it. And to see the output, we attach a wiretap. And we save the whole thing as audit runtime graphs, audit runtime graphs, and we'll save it to the menu audit. Now let's start the pipeline. You see it is sent over to the cluster and it's pending and waiting to get a slot. Now it's running. Let's open the wiretap and see the result. And here you see all the data that has been sent, but you also see that two messages have been sent. The first containing all the data, it's a small file, so everything is sent with the first batch. The second message doesn't contain any data, but it tells, okay, this was the last. The first was not the last. Our operators that we are going to develop will call DI REST APIs. To avoid adding the credentials as parameters to the operator, we will store the credentials as an HTTP connection to the connection management. Here you see this connection in the connection management. The first REST API we are calling is the graphs query of the pipeline API. So let's have a look to the API Business Hub to see the details. So we go to the pipeline API, the API reference, the runtime, and here is the runtime graphs query. And we see there are filters that we are using, that we are going to use, and this is the response, the data that we get. And part of it, we will not use all the data, but only part of it. So the user, the tenant, the source, the name, and so on. So these we will add to the vtype message that is now our next task. So back to the modeler, we have to add the new vtype that will define the output of the first custom operator that we are going to develop. And secondly, we have to add a header structure to pass the HTTP credentials from the first custom operator to the second one. So the data type, and we add first a table, and this we call audit, runtime graphs, audit runtime graphs, and the first one is the user. It's a string. The second one is the tenant. It's also a string, and so on. And then we go fast forward. And now we have all of a sudden the rest of the data that we need for this V-type. So we have, in addition to the tenant, the source name of the graph, the name of the graph, the handle of the graph, the status, the time of submittance, when it has stopped, the runtime of the graph, and finally the substitutions. That is, when you start a graph, you can add substitutions. The same have we done now for a header, for the new header that passes the HTTP data to the next custom operator. This time we have chosen a structure, and then we pass the host, the user, the password, the path, and the tenant via the header to the next custom operator. So now let's create a new operator. So we go to the operators, select generation 2, but this is also already selected because we have created a pipeline for using second generation operators. And then we say plus, and we name the new operator audit runtime graphs, audit runtime graphs. This is a Python operator of the second generation, and we add a new menu. For the imports, we name it input. This is the usual name I'm using. And the data type is a table. And because it receives data from a generic operator, or an operator that creates generic data, I'm using the wildcard. And for the output, I'm naming it output. It's also a table, but this time I'm using a V-type that I have created already. Good. So we have no tags, so there is no specific packages that I need here. For the configuration, the only configuration I need is I have to select the API. So I'm going here to the details and add connection ID. And it is of type object, and later I will add the properties of this object, of this configuration object, so it can retrieve the data from the connection management. Now we go to the JSON representation to add the details of this object, so the properties. For that, I'm going to my Visual Studio, and here I have already prepared something that I always use for these objects. Go back and replace objects. Okay, and we save it. Now I'm going to script and I'm uploading a script that I've already prepared and save it again. And finally, we add an icon. I always like to have my own icon instead of the default one. That's it, and save it. And now we can go and have a look to the details of the coding. The first part is a function that is called once the port input receives data, and it has a callback function as an argument, in this case on input. The callback function has basically three sections: preparation, that retrieves the data from the input message, might use header data, and reads the configuration; the processing section; and finally the section that sends the result to the output port or ports. In the preparation section of our custom operator, we firstly read the parameters from the configuration. What kind of data you get from the configuration object you can learn from the configuration types. For our HTTP connection, we read the host, user, and the password from the selected connection. The tenant is stored as a system variable. The data is wrapped in an object, and when streaming is not used, you get the content by calling just the get function. If there is no data in the message, then the callback function ends the processing with a return. This is important because we have learned that the previous operator sends messages with a header telling that there is no further data coming. The next section is the actual processing. In our case, it is a loop using the user stored in the second column of the received data and calling a function that is doing the REST API calls. The results are added to the list graphs. Let's have a glimpse to the function calling the REST API. The function getGraphs has two parts: the REST API call and the extraction and conversion of the data that is returned. The first part is using the Python requests package, and there is nothing special about it. It seems a bit strange that using a post for getting data, but this is the way the API is implemented. It might be because data is sent as payload for filtering. We are using this for getting only the completed graphs, and the completion timestamp should be later than the given. This is used to implement the delta feature. Otherwise, always all available runtime information would be sent back. The second part is extracting the data that we are interested in. The parameter substitution is stored as a JSON string. This is necessary because the v-types are not supporting structured data types embedded in a table data type. I thank the developers for skipping this additional complexity that would otherwise be used and the cause for hours of debugging. The result of the function getGraphs is stored in the list graphs, that is a list of dictionaries. First, we compute the latest completion time to know the filter of the next round of calls. Right now, there's only one timestamp for all users. Admittedly, it could be the case that graphs of the first called user completes after the data has been pulled, but before the time of graphs of later users have been completed. This would lead to lose these records. So as a feature for the next version, we have to save the last completion timestamp for each user. The next process step is to convert the list of dictionary into a data frame. This makes it extremely easy to sort the data columns according to the output v-type and create the two-dimensional list required. So with that, we have come to the third section. First, we create a new header. Headers are dictionaries with the key of the v-type identifier and a list of values in the order of the v-type. In our case, we create a standard header of v-type com SAP headers badge. By the way, the same header type that has been received. And add values as a list. It basically encodes this is only the one badge and it is the last one. The other header, audit connection HTTP, we have created previously, and here we add the configuration values. The next step might be redundant because we have defined earlier the name of the columns, but it is instructive to see how to confirm that the output is compliant to the output v-type. We therefore create a v-type reference of the output v-type and could then get the details of the v-type, in particular the column names and the sequence. This we use to reorder the data frame before creating a new API table data structure. This is then sent to the output. This call has the name output as an attribute to the class API outputs. The one of you who have already developed Gen 1 operators, this is different. Now we have completed the development of the first custom operator, audit runtime graphs. We add this operator now to our graph and start it to see if it runs correctly. So we have to save it and then go to our pipeline, search for audit. Oh, we have already here the audit, and put the operator in between the other two, and we have to add the connection ID. It's pipeline API save. So that's it. Save and run. And we finally see that the output of the operator produces the desired results. Now we have to create a second operator that looks into the details of each graph and extracts the used data sources. For this, we use the graph descriptions API call. I do not want to repeat the creation step by step, but move fast forward to when having created the operator already and the corresponding v-type. The additional v-type audit runtime graphs data sources, the data type of the output of the new operator has almost the same columns as the first table v-type, but without the substitutions. The additional fields are the connection ID of the data source, the data source type, the path of the data set at the data source, the used standard operator, and finally the direction read or write. The new operator is called get graphs data source. Let's have a look to the details. First, we see the newly created v-type graphs data source. there is no configuration because we will pass all the necessary information from the previous operator, and finally the script. Let's have a look to the main function, the callback function on input. Here we have at first the reading of the header, data, audit connection HTTP, for getting the credentials of the REST API call. Then we create a data frame with the column names we retrieve from the table vtype, before we call for each runtime graph the REST API to get the details, in particular the data sources. The result is stored in a data frame, and using the runtime graph handle as a primary call to do basically an inner join to merge both data frames. As a last step, we drop the substitution column that we do not need anymore. The REST API call function getGraph runtime details is again pretty much straightforward and returns the result as a dictionary. The function getDataSources is quite elaborate because there are different ways the standard operators store the information of the used data sources. There is nothing complicated in it. I have to admit I was expecting it would be more tedious. Eventually there had been only 3 cases, and for each a read and a write subclass. After we have got all the data stored in a data frame, we have again to convert it to a vtype table and ensure the right sequence. There's one additional step we need to take. The data frame stores null or none values in a special data type. These we have to convert into data types that correspond to the data type of the vtype. For strings, it is simply a blank string. For numbers, we need to agree what would make sense, in particular when storing the data in a database. In our case, however, we have only string data types. Now we have to save the operator and add it to the graph and test it. So all looks okay. Great. Right now, the graph is getting the runtime graph information and the data sources that are currently available. There is no delta feature that we plan to implement that enables us to run the graph permanently, and even when paused or crashed, knows the status and starts from the last successful data retrieval. This is what we are going to implement next. Let's open the operator Audit Runtime Graphs. We have already implemented a filter for the call, the time offset, from when to get the runtime data, and there is even a computation of the latest stopped graph. But this state is not saved. This is what we have to do now. I have copied now the resilience callback functions to the operator script. That will save the state, to be explicit, the time of the last stopped and completed graphs. I have initialized the operator for the snapshots. Second, the state needs to be converted to bytes that are saved using an epoch that is basically a timestamp. I use the 2-step approach via a string conversion before encoding the string. And the third step is, or the third callback function is the restore callback function that takes the epoch and an argument for the bytes and convert it back to an integer. Finally, we need to add a timer that starts the graph periodically. It is also a custom operator. But it is a very simple custom operator that takes the periodicity of as a configuration parameter and has the operator function add timer with a call function that returns the number of seconds, and this defines the time when the next message is sent. Now, after saving, we start the pipeline, but with run as, and give the running pipeline a name, and check the capture snapshots and set the number of times the pipeline should try to restart. Here you see all the data, the output is truncated, of the first call. Now we start for testing another pipeline, test table copy. And in parallel, stop the audit runtime graph and wait until the test pipeline completed. Then we resume the process of the audit runtime, and when running, checking the output and see only the recently completed pipeline. For saving the data, we could take the file producer or any other Generation 2 writing operator. So what have we seen in this presentation? The interconnectivity when having connected the file producer with our custom Python operator. We have created V-types, structures and tables and used them extensively. By adding the snapshot feature to one operator, we made the pipeline resilient and Delta enabled. And finally, we have seen how the separation of header information and data works. So many thanks for watching this video, and I hope you enjoyed it. All the objects I have created in this video are available as a solution that you can import into your SAP Data Intelligence instance. Go to my personal GitHub repository, DI-admin, and in the Solutions folder you will find the audit tutorial zip file. I wish you a successful coding.